Okay, so this is in 5.1. These are the later ones. So notice these graphs are less friendly than the early ones, but the key is finding the domain and range of these. And then knowing that, you can also plot a few points. So let's see here. So, and remember the good kind of domain and range analysis we did from before. So first we look at domain. With these is going to be easier. We're looking at, is there any restriction that I can put in for x in this exponent? And I don't have any like x in a denominator. I don't have anything under a square root. So there's no restriction here. But then when I think about the range, I think about, all right, what is changing? What has the variable in it? Well, it's the exponent. And so if I think about the range of negative x squared, well, the range of that, it's a parabola that opens down, so it's negative infinity to 0. So then I put that with the exponential piece. So I'm evaluating 2 from negative infinity to 0. And go through each piece. So 2 to the negative infinity. What's going to happen there? Well, that's going to get really close to 0, but not hit 0. And then the high point is going to be 2 to the 0, which is 1. So that gives me my range. And then, again, you are welcome to plot some points, and I encourage it. So first, I always try, there's no x-intercept here, but there is, and in fact, as it's getting closer and closer to 0, it may be helpful to analyze as x gets huge positively and as x gets huge negatively, what's happening. And in both cases, because notice the negative isn't in the parentheses, you're squaring x and then adding a negative. So in both cases, as x gets huge, it will be going towards 0. So I've got this horizontal asymptote of y equals 0. And then the y-intercept, when I plug in 0 for x, I get 1. It's an even function. Plug in negative x, I get the same y value. And so it ends up looking something like this. So for this next one, well, there's a couple ways to think about it. First, you may want to consider the domain and range. Domain, again, no restriction here. The range, well, let's look at what we would have the range of the exponent be. So it's a parabola that, again, opens down, but shifted up 1. So negative infinity to 1 would be the range of, would be the range of the exponent. And so then doing this analysis to the negative infinity, sorry, I didn't mean to write this over here. 2 to the negative infinity is really close to 0, and then 2 to the 1 is 2. But let's actually also, what might be helpful is comparing this to part A, because if I split up the exponent here, it's the same as saying 2 to the negative x squared times 2 to the 1, or 2 times 2 to the negative x squared. So it's just the previous graph, but vertically stretched by a factor of 2. So instead of this y-intercept being at 0, 1, it'll be at 0, 2, but we're going to have the same kind of then type of look. So that's kind of what you want to think about. Again, always welcome to plot points. As you can see in my solutions, sometimes when you have a quadratic, it may be helpful to put it into vertex form to get an idea of what's happening. Let's talk about, so that's going to be, the quadratic ones are going to be C and D as well. But let's talk about when an absolute value, because those are a little bit different. So let's look at 2 to the negative absolute value of x. And if you remember about an absolute value, you really want to write it as a piecewise function. The turning point here is at 0. So if I think about if x is greater than or equal to 0, that means inside the absolute value, I'm not doing anything. So I'm just graphing y equals 2 to the negative x. And let's that graph, if you remember from earlier in this packet, just looks like this exponential decay. But because we're cutting it off at greater than or equal to 0, we're only going to be taking this piece here. And then if we go back to now, if x is less than 0, then we're working on y equals 2. You would have to multiply what's inside the absolute value by -1. So it would be 2 to the negative x, which is just 2 to the x. So this graph would look like exponential growth. But again, we're only taking the piece for x less than 0. So we're looking at this piece here. So putting the two pieces together, this is a piecewise function that instead of like the previous ones with the quadratic, which were nice and rounded at the y-intercept, this is going to be nice and pointy because it's a piecewise function that cut off, and this y-intercept is just 0, 1. So let's do f of x is a little bit different. So let's do the same process though here. It's more of a transformation, so it ends up looking a little bit different. So let's first start if x is the turning point is 3, sorry. So if x is greater than or equal to 3, then we're talking about inside that absolute value being positive. So y equals 2 to the x minus 3 minus 4. So basically you're taking that 2 to the x graph, which is just exponential growth, like this one right here, and we're shifting it right 3 and then down 4. So this graph here would normally have this horizontal asymptote at y equals -4. And then if I plug in, so it's going to look like this. Whereas this piece here, again, normally the y-intercept in 2 to the x is 0, 1, but now it's being shifted to the right 3 and down 4. So that's why now this crucial point will be at 3, -3. But we're only taking the piece that's greater than or equal to 3. So we're looking at this piece right here. And let's do the other half. So if now we're looking at if x is less than 3, then I'm doing y equals 2 to the -x plus 3 minus 4. And let's actually rewrite that as y equals 2. If I take out a negative, it's x minus 3 minus 4. So a few things happening. Or we can think about, another way to think about it is we've got this negative here. It could be thought of as 1/2 to the x minus 3 minus 4. So it's exponential exponential decay. Shifted right 3 and down 4. So again, we're going to have this, if we were just graphing this, we'd have this horizontal asymptote at y equals -4. And then instead of like 1/2 to the x, would have a y-intercept of 0, 1. And now that point is moving to the right 3 and down 4. So this graph would look something like this. And now, but we're only taking the piece that is less than or equal to 3. So that's why when we put this together, we've got something that looks like that. So -3 inclusive to infinity. So just a little kind of absolute value review for you.